Okay, so if you want to find the curvature of this guy, there's actually a formula for curves in the plane, but to me it's not worth memorizing because you can use the formula for a vector valued function in curvature pretty easily. And to me that's easier than memorizing another formula because you've got enough to memorize already. So and also it's handy to remember how to parameterize this as a vector valued function. So the way we do it, anytime you have y equals f of x, and you want to parameterize it, in other words, another way of thinking of it in the Calc 2 sense is coming up with parametric equations is what we call them in Calc 2. So to come up with the parametric equations, which end up being the components of the vector valued function, all you do is, okay, the input, if it's y as a function of x, then, or x is a function of y, you let t be the input. So in this case, x is the input, so you let t be that guy, and then the output is automatically f of t. So your parametric equations become x equals t and y equals f of t. And that's generic. That works with any function. So in this case, what are your parametric equations? Well, the top one won't change. X equals t, and then y equals plug in t for x. So 8t to the 4th minus t, like that. Okay, so how do you write this as a vector valued function? R of t. Let's use component form since we haven't done that yet today. Yeah, why do you need that third component of 0? You do need it. Because we're going to use that formula where you take the cross product. And the cross product isn't defined for vectors in the plane. So you have to think of it as a 3-component vector to use the cross product on it. So once more then, we're going to use that formula for curvature. So curvature, k of t, is the magnitude of r prime of t cross r double prime over the magnitude of r prime to the 3rd. So we work it from the inside out. Let's find r prime. You guys help me out with that. R prime of t would be 1. 32t cubed minus 1, and I'll do the 3rd one for you. That's easy. I'll do the easy one. Get rid of 0, 0. And then r double prime. 0. Yeah, 96t. And then 0. T squared. Thank you. Does everybody believe that? Okay, so we got to find the magnitude of these, of the cross products. So that means up here we'll do r prime cross r double prime. Okay, set up kind of that pseudo-determinant, pseudo-matrix, pseudo-determinant. Why isn't it a real matrix? Well, a matrix is an array of scalars, right? You don't have vectors in a matrix, so it's not a, we just use the matrix notation because it helps us remember the formula for finding cross product. So across the middle then, we have 1, see if I can fit it in here, 32t cubed minus 1, and then 0. And then 0, 96t squared 0. Is everybody with me? All right, let's find that cross product. So you cross out this first guy. Oh, I think it's 0, right? Cross out the second guy, 0. So the I component, the j component, both 0, right? Cross out the third guy. That's the only non-zero one. So yeah, 96t squared times, well, okay, minus 0, but I'm not going to include that, times k, right? Technically, even though, well, in the next step, we're going to take the magnitude of it. That'll disappear. So what's the magnitude of r prime cross r double prime? It's a single component. So the magnitude technically would be the absolute value of the component, but it's 96t squared. It's always positive, or at least non-negative, right? So it's, you can just leave it as the component value because it's positive. Now, if it were like 96t times k, you would want to take the absolute value of it because magnitude is non-negative. Does that make sense to you? It's not so bad, right? Digging ditches is worse. Trust me, it is. What's r prime magnitude? Well, let's find, magnitude r prime, yeah. Ooh, what is that? That's not going to be very pretty, is it? Square root of? I don't even know if I want to multiply that out. I might make you guys do that if you want to, right? Not that it would be that hard to multiply out. And then we can set up that ratio now, right? So setting up this ratio, k of t would be 96 t squared over, okay, I'm just going to do the 1 plus quantity 32t cubed minus 1 squared, and then what do I raise that quantity to? Yeah, the whole thing to the 3/2 is a nice way to write it. I don't know if I wrote it that way in the answers, but I'm going to leave it that way here. So notice what that is. That's a curvature function. So for a given value of t, you put in the t, and the output is going to be a number, right? A scalar number. And the value of that is going to indicate how curvy the curve is, right? At whatever point that t value corresponds to when you plug it into r of t. So I didn't give you a particular value of x to plug in, but had I given you a value of x equals 2, well, x is t, so you would plug in 2 for t, and you would be able to get the value that way, right?